Okay, the first thing I'm going to show you is how to open up this document in Notability. Okay, so you should have the um, classroom open and you should see this link. By the time you see it, there'll be two links, but the Eureka Great Minds one is the one that has your document that you need. Okay, so once you open it, you're going to click on it, and it's going to open up into a brand new Chrome tab. And from here, what you need to do is double click in the bottom right corner of the screen, and you should get this open in um, button to pop up. Once that happens, you're going to hit the copy to Notability, and Notability is going to open up. You want to create a new note and import all. Okay, and these will be all your documents that you'll need, not only for notes for today, but as well as doing classwork when you're in class when I see you tomorrow. All right, anytime you import a new thing into Notability, the first thing you want to do is go ahead and change your file name. That way it's good practice for when you're taking notes and whatnot. So we are still in Module 7.1. We are currently in Lesson 3, which has to do with the proportional relationships in tables. Okay, so we have reworded all that. We're ready to go. Okay, so our goal for this lesson is for you to be able to look at situations, and they're all going to be in table form, and you are going to decide whether or not the two quantities that are being presented are proportional to each other. Okay, so you're going to do this by checking for a constant multiple between the measures of x and measures of y in a given table. Okay, so before we go on, we need to remind ourselves, remember our equation of proportionality. So our equation of proportionality is y is equal to k times x. Okay, so x is going to be anything that we're inputting, and y is anything that is an output. Okay, that leaves x as the constant value. Okay, which means it's just the multiplier for all x's. Okay, and our table is not labeled x and y yet, but I'm going to tell you now that our hours worked is going to end up being our x, and our pay, which will be our output value, is going to be y. Okay, so let's take a look at the example. It says, you have been hired by your neighbors to babysit their children on Friday night. You're paid $8 per hour. Complete the table relating your pay to the number of hours you worked. So the question you should ask yourself is, if the hours I worked change, does that mean the total pay must change? So take a second to think about to yourself. And yes, you should know that as the hours increase, your pay is also going to increase. We're going to see an increase in both. Okay? All right, so let's get started with our first hour. We know that if we work 1 hour, then we know that our total pay is going to be $8. Okay? And we know that because we have the hours worked times the pay rate, 8 is $8. Okay? We can say the same for the 2-hour mark. We know that if we take 2 and multiply it by 8, we know that we get $16. Okay? Same thing for 3 hours and 4 hours. Okay? Now we get to this very interesting value of 4.5. And that's possible. You can work 4.5 hours. So the way that we handle it is the same way that we handled all the other hours. So instead of it being 4 hours, now we have 4.5 hours. Okay, and this is where I anticipate some of you are going to get stuck. So we can handle this by working the problem with the fraction or turning our 4.5 into a decimal. And I'll show you both, okay, just to give you some review. So if we're going to leave 4.5 by itself, I'm going to add a little sticky here. Move this bad boy over here. Okay. If I'm going to leave it in fraction, I'm going to say 4.5 times 8 is equal to what? Okay. So I'm going to turn our mixed number into an improper fraction. Okay, and the way that I do that, I say 2 times 4 plus 1. 2 times 4 I know is 8 plus 1 is 9 over 2. Okay, this number I have to turn into a fraction. And 8 as a whole number I know is 8 over 1. And then multiplication is fairly simple. We just multiply across. 9 times 8 is 72 over 2 times 1 is 2. All right, and we need to simplify. And it comes to $36. Okay, now we can also do the decimal form, which I guess we can make this a little bit bigger. Or not. Add another sticky. Move from here. Okay, so I'm going to say 4.5 is equal to 4.5 because 4.5 is, or half is equal to the decimal 0.5. And I will say 4.5 times 8 since that is our pay rate. I know that 8 times 5 is 40. 8 times 4 is 32, plus 4 is 36. Okay, and as we learned in class today, if we have one decimal place in our problem, then we're going to move our decimal over 1, and our total is 36, which is perfect because that's what we got in the first place. Okay? All right. We also know that 5 times 8 is 40. Which is great because if we didn't know how to come up with the answer for 4.5, we just know that 36 is between 32 and 40. All right, and 6 times 8 is 48. Okay, we can treat 6.5 the way that we did the other one. So we can do 6.5 times 8 equal to 48 plus 4 is 52. 52. Okay, let's get this. Okay, I couldn't figure out how to move the sticky note, but under that sticky note it says, based on the table above, is the pay proportional? To hours worked? And how do you know? Okay, and the answer is yes. Pay is proportional because every ratio that we can get from the table, okay? So our 1 to 8 or 8 to 1 and 16 to 2, let's go keep flipping up, 16 to 2 and 24 to 3 and 32 to 4. All of them are the same. They're equivalent, right? And all of our hours, all we had to do is multiply by 8, and we were able to get the corresponding pay. So that's how we know that these ratios, or that X, which is our hours worked, is proportional to our pay, which is Y. All right? So that's what we are going to be working on in class tomorrow. What I want you to do is get started on, or try the first one, okay? So our exercise 1, to determine if Y is proportional to X and justify your answer. Okay, so go through the whole process.